Welcome to our video lectures on fax devices. We shall continue today also with our shunt compensation. Today we are going to discuss about Dstatcom. So, Dstatcom, this will be essentially it is a distribution Statcom. In previous lectures we have seen the SBC and the Statcom, and both were put for the shunt compensations, and we find that there is a big advantage of the Statcom over the SBC. Now, those who are connected mostly to the transmission line, and thus it is require a high voltage. This is put into high voltage applications, and it requires step down transformer and those things. Dstatcom is also now the part of the fax devices and the power quality, and it is generally used for mitigation of the harmonics, moreover with the compensation of the reactive power. The concept of the fax was developed originally for the transmission line network. Last 15 years it has been extended to improve the power quality. So, power quality also comes into the purview of the fax device nowadays in distribution system operating at low or the medium level voltages. In the early days, power quality referred to mainly the continuity of the power supply at acceptable voltage and frequencies. Now, another parameter has been added to monitor the power quality. Present day AC distribution system are facing number of power quality problems, especially due to the sensitive equipment in most of the industrial and the industrial, residential, commercial and the fractional application. The power quality problem today are now classified as a voltage and the current quality problem in distribution system. Due to advent of the power electronics, we have nonlinear load. A load not only cause PQ problem and also very sensitive to the voltage deviation. PQ problem, that is real power and the reactive power problem, is defined as any problem manifested in voltage, current or the frequency deviation as a result of the failure or the miss of the operation of the customer and or the equipment. Statcom, on the contrary, the Statcom connected at the distribution system and operating for the mitigation of the multiple current and the power quality problem is known as Dstatcom or distributed Statcom. It is abbreviated as Dstatcom. There are number of current based power quality problem such as poor power factor, poor voltage regulation, current harmonic, unbalanced current and the increase the neutral current. These are the problem of the poor power factor. Now, Dstatcom technology is now a mature technology for providing the reactive power compensation, load balancing and neutral and the harmonic current suppressions in the AC main networks. Dstatcom is also used to regulate the terminal voltage, suppress voltage flickers and improve the voltage unbalance for the 3-phase system. This is one of the utility. Classical technology for using power capacitors and the static var compensator using TCSC has been used to mitigate some of these problems. But the Dstatcom technology is considered the best technology to mitigate this current based power quality problem, and thus it has been used frequently in fax devices. Dstatcom can be categorized into the 3 types. It can be single phase 2-wire type, and it may be actually 3-phase 3-wire system, that is 3-phase 3-wire type. Dstatcom can be 3-phase 3-wire type, and 3-phase 4-wire type configuration is also put into the perspective. So, this is 2-phase 2-wire Statcom has been investigated and varying configuration and control strategy to meet the need of the single phase, and this is generally for the low voltage application, and this does not find much application nowadays because distribution system are mostly 3 phase 4 wire or 3 wire. In this configuration, both current source converter, that is CSC, with inductive energy storage, and the voltage source converter, that is VSC, with capacitive energy storage are used to develop the STATCOM. The 3 phase 3 wire STATCOM were actually reported in 1984 by Akagi et al. So, that was a historic configuration that has been reported. Many configuration and the control strategies such as instantaneous reactive power theory, this is also proposed by Akagi, synchronous frame DQ theory, synchronous detections of methods are used for development of the 3 phase Dstatcom. The problem of the neutral current and the unbalanced load can be resolved by using actually 4 wire system in case of the 3 phase 4 wire system or 4 wire Dstatcom. In 4 wire distribution system, which causes reduction of the neutral current, load balancing, reactive power compensation and harmonic compensation. The problem of reactive power and the load balancing have been recognized long ago, and they have got aggravated in presence of the nonlinear load. Many more terminologies such as static var compensator, static flicker compensator, static var generator can be used for the same configuration or the literature. One of the major factor of advancing the Dstatcom technology is the advent of the fast self computing solid state switching, because IGBT, mostly IGBT are used in this configuration. IGBTs are find huge application in this configuration. In the initial stages, BJT and the power MOSFET has been used to develop the Dstatcom, and with the introduction of IGBT, nowadays IGCT, the Dstatcom technology has got a real boost at present, and it is considered as an ideal solid state device for the Dstatcom. Now, moreover, improved sensor technology, especially the Hall effect sensors and the voltage sensors, also contributed to the enhanced performance of the Dstatcom. The next breakthrough in the Dstatcom development has resulted from the microelectronics. The processor capability has increased drastically. So, DSP microprocessor etc., and its computing ability. Now, it is possible to implement the complex algorithm online for the control of the Dstatcom at a reasonable cost. With this improvement, the Dstatcoms are capable of providing corrective action even with dynamically changing load such as furning or traction, furnaces, arc furnaces or the tractions. Now, this is the overall configurations of the Dstatcom. You have 3 phase 4 wire balanced or unbalanced load, and you may be actually feeding with the highly inductive diode bridge rectifier, and this is the your Dstatcom. So, it is a voltage source current control inverter. This is a 3 leg VSC based 3 wire Dstatcom. The function of the Dstatcom is to mitigate the most of the current based power quality problems such as reactive power, unbalanced power, zero sequence current or the neutral current, and the harmonics, to provide sinusoidal balanced current in the supply with the self supporting DC bus of the VSC used for the Dstatcom. An IGBT based current controlled voltage source converter CCVSC with the DC bus capacitor used for the Dstatcom. The VSC uses PWM control, therefore, it requires small ripple filter to mitigate the high frequency switching ripples. Using a control algorithm, the reference of the Dstatcom current are directly controlled estimated by the reference of the Dstatcom current. We shall see that how does it work soon. The gating pulses of the Dstatcom are generated by employing the hysteresis or the PWM control over reference and sensed supply current, resulting in a indirect current control. Using the Dstatcom, the reactive power compensation and unbalanced current compensation are achieved in all the control algorithm. In addition, 0 voltage regulation ZVR at PCC is also achieved by modifying the control suitably. The main objective of the control algorithm of the Dstatcom is to estimate the reference signal using a feedback signal. This reference current along with corresponding sense current are used in PWM current control to derive the PWM generating signals for switching device of IGBT of the VSC used in Dstatcom. The reference current may be estimated by using the number of control algorithm. There are many control algorithms reported in the literatures for the Dstatcom, which are classified as time domain and the frequency domain control. So, we shall see that what kind of actually reference generation technique is available. The few of this control algorithm are as follows. So, we have reported 13, do not consider it as unlucky. So, there are many. So, these are all time domain algorithm, unit template technique or the PI control based theory. This is a very simple technique. Thereafter power balance theory, thereafter I cos phi control, current synchronous detections or CSD method, instantaneous reactive power theory. This is very important and it is proposed by the legend of this field Akagi, IRPT, and is known as the PQ theory or alpha beta theory. Synchronous reference SRF theory known as DQ theory. This application first done by Subhasis Bhattacharya et al. For investigating shunt active power filter, and instantaneous symmetrical component theory ISCT, single phase PQ theory. You can extend this 3 phase logic to the single phase, then it will be a single phase PQ theory. Same way you can have a DQ model in single phase, and then their quadrature, they are phase shifted by the quadrature, then you can have a single phase DQ theory. Neutral network theory. So, it is an optimization of the weight by the NN. So, we draw LMS based Adeline algorithm where it can tune online. Enhanced phase lock loop based control algorithm. So, here PLL actually does the reference generation. Conductance based control algorithm. So, we have to actually maximize the conductance. Adaptive detection of the control algorithm known as the adaptive reference of the cancelling theory. These are the few technique that are used in the current domain, and there are many, but generally we are restricted to actually first 6 techniques for the 3 phase 3-wire or 4-wire system. Now, we have frequency domain algorithm. These are Fourier series theory. You can actually take a sample and do the FFT and find it out. So, discrete Fourier transform theory, DFT. First Fourier transform, it can compute very fast the components of the fundamentals. And recursive discrete Fourier transform theory, it can actually it can employ the sliding window and thus compute this actually the harmonic components and the other component very fast. Kalman filter based control algorithm, that is also used in practice, and wavelet transformation theory that is well stated nowadays, but constant is there, we have to design the mother wavelet very properly, then only we can detect the time as well as the harmonic content in the wavelet. Stockwell's transformation or S transform theory and empirical decompositions, EMD transformation theory, Hilbert-Hung transformation theory, these are the few techniques may be used for estimating the reference. All this control algorithm may be used for the Dstatcom. So, that is a categorical statement. To get the basic understanding here and for the time constraint, here we shall discuss few important control technique or reference generation technique. Only two of them is explained here, which is commonly called instantaneous reactive power or theory, or known as PQ theory. It is proposed by Akagi, and another is another very common theory, instantaneous reference frame SRF theory, known as DQ theory. Both the theories, both these things applied for 3-phase 3-way system. The IRPT based control algorithm of the Dstatcom is been designed. The 3-phase load current sent to the is sends PCC at the common probable voltage and used to calculate the instantaneous active and the reactive power. The 3-phase PCC voltages sensed are processed through the BPF, that is band pass filter, generally it is a low pass filter, and before their transformation to eliminate their ripple content such is denoted by this. Generally we can use a first order Butterworth filter for BPF. So, we can write down the matrices. This 3-phase filter load voltage transform into the 2-phase alpha beta orthogonal coordinates. So, alpha beta equal to root 2 by 3, and this is the matrix, transformation matrix, and this is VA, VB, VC. Similarly, we can transform the current. This 3 load current IL, IB and all those things are transformed into the alpha beta pair in I alpha and I beta. So, thus the IPL and IPQL can be written in this way. From these two sets of expression, the instantaneous active power PL and the instantaneous reactive power QL flowing into the loads are computed as PL and QL equal to V alpha V beta and V beta minus V alpha equal to I alpha into I beta, and this bar stands for the DC value. If IPL and IPL delta are the DC component and the harmonic component of the PL respectively, or the average value of the harmonic component, and similarly QL and the QL delta are the DC component of the DC component and the AC component of the reactive power respectively, then you can write PL equal to the DC value plus the harmonic value of the power, real power, and similarly QL equal to QL plus QL delta. In the above expression, the fundamental load power is transformed to the DC component, or the negative sequence transformation, negative sequence is transformed to AC component. The DC component of the active and the reactive power are extracted by LPFs. From this reference 3-phase supply current ISA, ISB and ISC are computed. So, ISA, ISB, IC equal to root 3 by 2, and this is the value of the IP star and the IQ star. So, what this at IPRF said? This IPRF based control algorithm may be modified for the control on the supply current for indirect current control. PI controller based shunt active power filter or the Dstatcom are said to be the direct current control. In this case, the power factor correction mode of operation of the Dstatcom is P star equal to PL plus P loss. Similarly, Q star equal to QL minus QVR. In terms of the P loss, the instantaneous reactive power is necessary to adjust the voltage of the DC capacitor of the SBC as Dstatcom to the reference value. In addition, QVR is the instantaneous reactive power necessary to adjust PCC voltage for its reference value. The phase transform current R, reference supply current, and this must be compared with the sense supply current in the PWM current controller for indirect current control of the Dstatcom. Now, this is the model. So, VDC LPF. So, VDC minus, so there is a PI controller that will maintain the DC bus voltage, and from there the P loss term will be calculated, and you have a current sensors and the voltage sensor pair of the voltage sensors that will estimate the that will actually sense the voltage and current, and that is fit to the Klutz transformer block that is being computed by the microcontroller or DSP based processor online. So, thus V alpha, V beta, I alpha, I beta is been computed. From there actually PL and QL is been computed. So, from there essentially you will sense the actually the V at the point of common coupling and VSC star, and from there we will sense the reactive power, and thus you get a VQ. From this matrices basically the reference I alpha and I beta is computed, and you can go back to the 3-phase system and alpha beta to ABC frame, the reverse Kirk transformation, and you can operate the current control voltage source inverter and by the gating pulses. This is the principle of operation of IRPBD based control signals. Now, in this case of the ZVR or the zero voltage regulation at PCC, the voltage regulation mode of operation of the Dstatcom. A PI voltage controller over the PCC voltage is used similarly to the above algorithm, and its output voltage is used to estimate P star and Q star as P star equal to PL plus P loss and Q star equal to QVR minus PL. After transformation, this 3-phase transform current are the reference supply current, and this compared with the sense supply current. So, SRF theory based control algorithm, and we shall discuss now that actually first the unity power factor operation. In this control strategy, the reactive power compensation of the UPF operation considered as a supply must be delivered the DC component of the direct access component to the load current IDC along with the acting component maintaining the DC bus voltage and meeting the losses of the Dstatcom. The output of the PI controller at the DC bus voltage of the Dstatcom is considered as a current I loss for meeting the losses. Therefore, the reference current what we have shown previous slide, this one is basically IDC plus the I loss. So, this is the I loss. Similarly, same thing is carried out for Q axis. Now is actually the reference current supplied must be in phase with the voltage at PCC with no zero sequence component, that is a requirement. It is therefore obtained by following the reverse Parks transformations, and thus we set ID, IQ and as 0. So, you can calculate this reverse Parks transformation and you make I star 0 as 0. So, there is another operation that is called ZBR operation of the Dstatcom. This controllability of ZBR operation of the Dstatcom is considered that the supply must deliver same direct access component ID as mentioned by actually unity power factor operation of the Dstatcom, along with the difference of the quadrature access IDQC of the load and the component obtained from the PI controller and IQR used for regulating the voltage and common coupling PCC. So, both require to be supplied. The amplitude of the AC terminal voltage VSP at PCC is controlled to its voltage reference VSP star, the PI from the PI controller. The output voltage of the PI controller is considered as a reactive power component of the current, that is IQR. For the 0 voltage regulation, the AC voltage at the PCC, it has to be maintained. Now, so we can find it out what should be the amplitude of it by this following equation. The amplitude of the VAC at point of common coupling can be calculated in following way. Then PCC voltage is controlled, a controller is used to regulate the voltage at the reference value, and thus you can have a calculation of the IQ star, and IQ star is calculated IQ DC minus IQR. So, the 3 phase reference supply current are obtained by the reverse Parks transformation is transmitted to ID star and IQ star in the equation, and this IQ 0 is set to 0 strictly. The reference supply voltage is been calculated from the reverse Parks transformation, and it is fed to the current control PWM block to generate the reference current. In that way, actually we get the switching signal for the current control voltage source inverter for Dstatcom. So, we will continue with the next class. Thank you.